Well, hey, class. I think we're live and in action, streaming out to the universe. Yeah. So, are we able to? Hey, class.
We'll redo that. One more time. Are we back on? Yeah, we're back on. Okay, yeah.
You guys are too kind. Thank you. Thank you for all the applause. Not deserved yet, but it will be, I'm sure, as soon as Emre is done speaking today. We have a really fun class here. I think you guys are all going to get a lot out of it. I know I'm super excited to learn from this master of Polkadot and all things potentially Substrate and related. Emre is from the Web3 Foundation, and I'd really like to kick it off to him to introduce himself more formally. But just before we do that, I think there was some brief announcements that we wanted to get from Tim and Malin. Is that correct? Before we get started here.
Yeah, we do that at the end of the session.
Okay, cool. So we'll stick around to make sure that that's good. Then we'll kick right off into the workshop, guys. So hopefully you guys are ready to do a wild ride through how and what Polkadot is, all the way through some cool applications that are built on top of it already. With that, I'll kick it over to Emre.
Awesome. Thanks, Dan. Hi, everybody. My name is Emre. I am a technical educator at the Web3 Foundation. As much as Dan said I'm a master, in training, it feels like forever. There's so much to learn and everything is always changing super quick. But I'm excited to talk to you guys about where we're at, what Polkadot is, what Substrate is, and then we'll dig into some code as well. So with that being said, I think let's just get started. I'm going to share my screen and let me know, just holler if something disappears or it's lagging or...
Let's see. It was, at least for me, like your picture was coming in a little bit choppy. Was that for you guys too?
Yeah, it's slightly choppy.
Yeah, so because the new M1 chips came out and I don't have one, you know, it's baked into the older computers to start degrading as soon as the new stuff comes out. So unfortunately,
oh well,
I don't know if I'm going to be able to fix it.
It seems to be good now. Your slides are coming through all right for me, at least.
Cool. It's loading for me. So yeah. Thumbs up. Let's get into it. All right, so this is a dive into Polkadot and Substrate. So Polkadot is founded by Gavin, Robert, and more recently Bjorn joined us. So Gavin would develop the first version of the Ethereum runtime and the Solidity smart contract platform. As he was developing that, he had this vision of how and what the next version should be like, and that's what Polkadot is. Robert is a lead hacker who's on the team hacking away at most of the features like the parachains, things like asynchronous backing, things like governance, and just essentially taking what research does and leading the coding side of it. And then Bjorn is our CCO. So we have a philosophy. As you know, this Web3 thing is blowing up and we're still trying to define it. We don't really know where it's going to land, but our philosophy is that it lands somewhere where a decentralized fair internet in which people own their own data, their identity, and hence their own destiny. So that philosophy is being pursued by the Web3 Foundation, where I'm at, and Parity, where Dan is at. Parity is kind of the development arm business. Web3 is kind of the research, education, grants, and together we work together to try and get to our vision of Web3. So how does Polkadot fit into that? Well, Polkadot is this protocol that is a layer 0 blockchain. It's a heterogeneous multi-chain, actually, that connects and secures L1 blockchains through pooled security and interoperability. So what does that really mean? It means that imagine what TCP/IP did for the internet, right? So it allowed these nodes that were previously isolated, that couldn't communicate with one another through a shared protocol, and the TCP, so the Transfer Control Protocol, designed a way to chop packets up and send it around and make sure that there is a uniform way to do that. And that way, nodes started to be able to interoperate together, so you could pass around data. And so essentially, that's what Polkadot does for the blockchain realm, where Bitcoin, Ethereum, these type of L1s that are application specific or generalized, are isolated networks. They don't really have ways to communicate with one another. And so Polkadot wants to be that communication layer, as well as an ability for new ideas to be developed on it. So why? Well, the interoperability, right? I just talked about that. It makes it easier for these isolated chains to be able to communicate with one another. And what we believe is that the real applications of this Web3 realm is going to come when this interoperability gets figured out, because then you can compose blockchains that have cool applications, like one does identity, one does security through different types of cryptography, one does decentralized finance, one does social media. So you can kind of compose those together to make really cool apps. So pooled security is really important, and it's actually really, really awesome, because if you imagine how Bitcoin came to be, it took a while for it to get to the type of security it has right now. So it's very expensive to attack a network like Bitcoin that has a lot of participants, a lot of nodes securing it. So the cost of attacking that network is quite high, but it didn't used to be. And now that we know how blockchains and networks work, something like pooled security is extremely important, especially if you're developing new blockchains. And early on in their life, they're going to be very vulnerable to certain types of attacks. So pooled security is great because Polkadot has established a large amount of security, so it's very expensive to attack the network. So if you have a new blockchain and you connect to Polkadot, you're already as secure as the main network. So that's really awesome. And heterogeneous chains. So this is our vision of sharding. If you're kind of following what Ethereum is doing with ETH 2.0 and sharding. So sharding is this kind of paradigm of how to scale these blockchains. And the way that our blockchain works is that we have what are called parachains, and these are our shards. These are our kind of like consensus, like you can have different types of parachains that have their own consensus mechanisms, that have their own block time, that have their own coins and economics and game theoretic kind of applications, all running on Polkadot. They don't have to buy into a certain type of design pattern like Ethereum has, like with ETH 1.0. If you want to release some sort of a dApp on ETH, you have to play by the ETH rules. And if there's an NFT release on some dApp that has nothing to do with your dApp is therefore impacted by the throughput of the other application. So that's what kind of like this heterogeneous sharding is. And then on-chain governance. So this is extremely important because this is one of the ways that token holders have all the say in how the network develops. So any type of runtime upgrade, any type of feature that gets proposed, any type of funding, on-chain funding that gets proposed goes through governance. And if it doesn't pass governance, which is a quite complex system on its own, then it won't get enacted into the chain. So our architecture is extremely scalable as well. We have this relay chain, which is the main chain, and then pair chains that connect to that relay chain. So the relay chain creates that pooled security, interoperability, so it allows connected chains to communicate with one another and then share security. There's different ways to connect to the relay chain. There are pair chains, there are parathreads, which are kind of like light parachains. In a like a technical way, all parachains are by default a parathread. So if your parachain gets downgraded somehow, and I'll talk about what that means, it goes to being a parathread. And then there's bridges. So sometimes you just want to create a bridge to an existing L1 like Bitcoin. So there's different ways to connect to the relay chain. And that like communication interoperability layer that I talked about, similar to how TCP works, we have what's called XCM, the Cross Consensus Messaging Protocol. So this is a protocol that doesn't care about what type of messages are being passed around. So you can pass around transaction information, you can pass around NFTs, you can pass around tokens, you can pass around state information, like what's going on one chain versus another. And there's ways to cross-chain communicate. So there's cross-chain message passing, meaning parachain to parachain. Some other ways of message passing are developed. So upwards message passing, meaning from the relay chain to the parachain, or downwards message passing, parachain to relay chain. So this is kind of like one of the main components of Polkadot, and what allows relay chain to allow parachains to communicate. So what's really important also in the blockchain realm is in Web2, if you're developing an app, you're going to have test networks, right? Like, so you're going to deploy something that's like, oh, the button is the color that I coded and the functionality is working. Okay, great, let's push it to production. Unfortunately, it's not that easy in the blockchain realm, because we have so many game theoretic, real world kind of interaction between participants aspect. It's not as easy to test new features and new developments on blockchain. So that's why Kusama exists. Kusama is a canary network, almost has all the same parameters as Polkadot does, except it's a little bit faster. So it's some of the parameters are about allows it to develop, the chain kind of runs 4 times as fast. And so any type of application, any type of parachain, any type of token design can get tested on Kusama, which has real value-bearing token, its own token called KSM. So you can test out your economics for your blockchain on a real network. And actually, it's starting to become its own full-fledged network, where some projects are not choosing to go from Kusama to Polkadot. So Kusama is like this cool developer, like work fast, break things, try things out, experiment, and if it works, put it onto Polkadot type place. So building on Polkadot, so Polkadot uses a framework called Substrate, and we're going to dig into that. What Substrate allows is, Substrate is the first well-designed framework for building blockchains. It's built on the Rust language. So Rust is a systems level language that has some really useful kind of error handling, ability to interact with hardware, kind of like memory management, ability to do tests. So it has this really one of the best development environments that I've seen. And Substrate is built on top of that. So building on Substrate, you can build a parachain, and it connects to Polkadot, which is also running on Substrate. And during the development of Polkadot, so this is like a very engineering approach, the team was like, we need a framework, right? So blockchains have all these shared components like accounts and cryptography, and the idea of wallets, the idea of consensus, the idea of block time, and all of these things are going to be, repeated over and over again when you develop blockchains. So why not just package them up into small modules that can be used kind of like building blocks? So Substrate is exactly what that is. It's like a Lego world for building blockchains. So yeah, Substrate. Hi. So Substrate has these things called palettes, and these palettes are those modules that I talked about. So you can literally go into all the palettes that Parity has built so far and pick and choose what you want to include in your blockchain. So for example, we have a few things here. We have atomic swaps, pseudo, which is like a super user account that allows you to do anything. Assets, so things like fungible and non-fungible assets. Treasury, so you can have an on-chain treasury. The idea of a timestamp. Election pragman, which is kind of what is used for governance and electing nominators because it's a proof of stake network. EVM palette for running ability to have a Solidity runtime, multi-sigs. So all of these things are packaged up and ready for you to kind of like include in your runtime, and they're out of the box, so they work as soon as you include in your runtime. Cool. So it's like this modular framework, right? It has seamless integration. It has this idea of on-chain governance. And so as soon as you, so for example, how Polkadot was released, well, as Kusama first, and then Polkadot, is that it started as a proof of authority network. So proof of authority is something that has super user powers on a single account, and you kind of have the control over them. And slowly it started decentralizing through signaled interest from the community to become validators. So we started to actually through governance as well, remove the pseudo power. So then the governance only allowed for the token holders to participate. So runtime upgrades to include things like account balances, and then transfers were slowly introduced into the system as it decentralized, as it was safe to decentralize those things. And you can choose to do the same if you were to build your own parachain, or choose to do it a different way. So that's kind of like this idea of scalability. So Substrate has, through some of its consensus mechanisms, really fast transactions speed, which is a variable. So it compiles also into WebAssembly. So your runtime is a WASM blob. So WebAssembly, in theory, could be written in any language. If you were to choose, it makes it easy to develop, different types of in different types of languages. You compile it to WASM, and then your runtime just gets included inside of the block if it gets enacted through governance. So there's this idea of forkless upgrades. Substrate removes the idea of forking, which sometimes splits networks, splits communities. It seems to, have had a lot of effect on Bitcoin and Ethereum in the past. So that's kind of like the upgradability, right? So what happens on Polkadot is if a runtime gets proposed on governance, the runtime will get voted on by the token holders, and a WASM blob will be included into that proposal. As soon as the proposal passes, there's this function called setCode that will enable the WASM blob to update on the block that it's included. So if this is kind of upgrade to include, let's say, non-fungible assets into one of the chains on Polkadot, it doesn't require a fork anymore to be able to do that. Right, so building blockchains, building client apps, ability to deploy, monitor, all of these things are included in this rich ecosystem. So interestingly, becoming a parachain, anybody can become a parachain, but first they have to kind of signal that they deserve to be a parachain. They need to be able to have a good application and then a good community backing them. And what happens is the parachain slots are auctioned off to the highest bidding parachains. There's this idea of a candle auction that's used, that's enables kind of, a more fair way of auctioning these slots off. It's not kind of like an eBay type of auction where you can wait till the last minute and try to do, what's called auction sniping by trying to beat the highest bidder. The candle auction retrospectively uses a randomness function to choose a time in the past. So the winner is kind of randomly chosen, and that incentivizes parachains to put in their bid as soon as possible. Kind of a cool functionality. And you can increase your bidding power by running a crowd loan. So if you have a good community backing you, they can increase your bidding amount. Can probably skip that. Okay, so where are we at now? So our ecosystem is, I think there was recently something that came out that the number of developers that we have in our ecosystem is second to Ethereum's. It's growing exponentially. We have 150 chains in development, a bunch of APIs and tools and services that are live, like chain explorers, wallets, over 18 production networks have launched on Polkadot and Kusama. And in total, there's about 50 billion in market cap combined between all the chains that are running on this network. So here's some interesting ones. So we got DeFi, NFT, gaming, smart contracts, identity, privacy, bridging, IoT, supply chain, social networks, enterprise stuff. And some of these are already existing projects that had a ERC20 contract or their own implementation of a blockchain that they chose to then become a parachain to take advantage of the interoperability and the shared security that Polkadot provides. So there's a lot of opportunity in the ecosystem to develop decentralized applications by composing these different chains. And the development environment is being, progressively, more support is being added. We have a few really good block explorers. We have our Polkadot.js client UI, so I'll show you that. A good amount of wallets that are using all of these different types of functionalities to allow you to do crowd loans and stake and do transfers. And there's builders programs. So we're constantly developing our ecosystem. If you have a good idea, if you have a dApp that comes out of this class and you want to take it to the next level, there's a lot of opportunity to be able to make it a legitimate project. Duplicate slide. All right, so, and on top of that, Web3 Foundation has grants. So I implore everybody in this class to utilize some of these programs to fund your ideas. There's a lot of untapped resources if you want to continue on into this world. And at the Web3 Foundation, we're trying our best to fund as many good ideas as possible. So we're looking forward to hearing more from people like you guys. Also another funding mechanism is our on-chain treasuries. So there's millions of dollars worth of cryptocurrency waiting to be given to projects and ideas that will improve the ecosystem. And then there's accelerators and incubators, so boot camps, ventures, the DeFi Alliance. So these are things that are also throwing money at great ideas. All right, so developing with Substrate. What does that mean? So Substrate is this modular, flexible, extensible framework, right? So, and then we're gonna use a framework. So it's a framework of a framework that creates these modular packets and allows some hand-wavy magic to happen when developing your, so essentially what that means is it's abstracting away kind of the difficult boilerplate stuff that you don't have to worry about, and you can just focus on your application. So the relay chain is something that will be useful to interact. So this is the Polkadot.js UI. And then we have test nets. So there's Westend, Canvas, Rococo. These are test nets that can be deployed to test out functionality before it can go on to something like Kusama. And Substrate gives you technical freedom. So if you want to choose an easy development route, like what we're going to take a look at today, running your own Substrate node and designing a palette, or using Frame, or using just Substrate core, which requires you to you can go as far as developing your application in non-Rust languages if you use Substrate core to compile it down to WASM. I think that's obviously slightly out of the context and the scope of this course, but essentially there is that ability to, and the flexibility to do that. So essentially we're going to take a look at how frame palettes can be chosen and included in your runtime, such as that way. And the anatomy. So this is something really important to understand. libp2p, that is kind of the networking layer of, I think, every single blockchain that exists. WASM is that kind of WebAssembly blob ability to have runtime, forkless runtime upgrades. And Grandpa is the consensus mechanism. So let me spend just a couple of minutes talking about the consensus of and the finality mechanism of Polkadot. It's actually quite complex, but it has some really cool implications. So Grandpa is this ability to finalize multiple blocks at once. It's a deterministic approach to finalizing the state of the chain. And it has some assumptions baked into it. Let's just say that Grandpa is happy as long as 2/3 of all nodes are in agreement, okay? And so as long as 2/3 of nodes are in agreement, every time a new block is getting, added to the chain, Grandpa is like, great, let's just add as many into the chain as I can. So this is kind of the deterministic approach that has a probabilistic fallback. And that's called Babe. And so Babe and Grandpa work together to have very quick finality on-chain. Grandpa, because it's deterministic and has some edge cases, Babe is there to kind of have this canonical longest chain approach that Bitcoin has in its type of finality. So it's what we call a hybrid consensus. And it's really cool. So it kind of, that finality consensus works hand in hand with the proof of stake algorithms that run to kind of make this whole idea of consensus. So awesome. And you can include that in your runtime. And what's cool about Substrate is if you want to have some sort of a different custom finality, etc., it allows you to do that. And so what we're going to do today is we're going to take a look at a template called the Substrate template node. This is kind of an out-of-the-box Substrate node that you're going to be able to see what it looks like running a node on your local machine. It starts as a proof of authority network with pseudo power on a single account, so you have kind of full control over the network. And you can kind of customize your functionality from there. We're going to walk through what a Substrate palette is. Palettes are those kind of modules that we talked about. However, you can also develop your own palettes, and we're going to take a look at what that means. And then you're going to be able to see what type of palettes exist, and then take a look at what they enable on-chain. Duplicate slide. All right, so let's run a node.
So awesome, Emre. Maybe we could pause here because we went through so many concepts and topics here. I wonder if it'd be worthwhile to take some questions from the audience and see if the class had any particular things that they wanted to know.
Yeah, great.
Yeah.
Awesome.
Great
Okay,
idea.
do we got questions that you'd like to ask? Now's the time. Or so far, so doing okay? Doing good? Thumbs up.
If you're anything like me, that was dense. That was super dense. Like it's a year's worth of knowledge in 20 minutes. It's a lot of moving parts in the Polkadot network, that's for sure. I might have some questions. So in the context of this class, everybody is building like a startup solution, right? So you mentioned some grants and things that are available. So there's like end users out there in the world. Is there any examples that come to mind for like what end users are examples of cool parachains that have used Substrate and like built something interesting?
Yeah, definitely. So I would say there's parachains that have been developed from scratch that are worth mentioning, I think, are the ones that won the first auctions. So Akala is a great team developing a DeFi substrate-based DeFi chain, and not only DeFi, but kind of this thing called like hi-fi, hybrid finance. So they're bridging traditional finance and DeFi together. And then there's another really cool one called Moonbeam. Moonbeam is essentially a Ethereum virtual machine runtime, but with Substrate. And then some non-parachain projects that are in the ecosystem that are really cool are some of these wallets. So there's, wallets being developed that use these kind of like on-chain funding to develop their ideas, such as Talisman or Fearless, or these teams that have great ideas to develop the ecosystem that can do it through these funding mechanisms.
Rock on. So I dropped the link in the chat here too. If you're curious about some of those parachains, parachains.info, I think is kind of becoming the canonical source of like what parachains exist and what relay chain they're on, if they're on one of the Polkadot network or the Kusama network or not deployed yet, or what it is. And then I think that the Polkadot network has some examples of like the wallets that are being developed and stuff like that. Or where's the best place to find out about those?
Yeah, I really like. Am I still sharing my screen? One sec. Let me just drop this. What was it? .treasury.com.
Yeah, you're currently not sharing your screen.
Not yet. Yeah.
Yeah, I'm not on purpose. I'm just going to share the link. So this .treasury.com is a great place to see the treasury funded projects. If you just click on projects up there. So there's some chain explorers, wallets, swap, AMMs, a bit like kind of UIs to see what's going on chain, like Polka assembly.
Cool. So like in this whole like crazy system though, right? I think that the purpose really of Polkadot is to abstract a lot of the things that we just talked about, all this complexity and like grandpa's consensus design and all this stuff, to the point that you don't need to think about that, right? Especially as a parachain developer or someone who's building in this class, a lot of those concepts are important to know about, but how much you actually have to interface with them is very little. Like in terms of building one of these parachains, core concept there is to really focus on what I think we're about to get into, right? Is that logic that makes your blockchain unique. And then all the rest can potentially be done with Substrate plus Polkadot so that you can build your cool application that's actually running out in the world and is secure, like what a blockchain should be, notional, right?
Yeah, exactly. And there is, I'm going to dig into this Polkadot.js UI that allows you to interact with almost all parachains that have been released on production so far. So if you look into, a parachain that, is useful and you'd like to build a dApp on, Polkadot.js allows you to interact with that.
That's pretty cool. That's kind of a superpower too. You're building a unique blockchain that you can immediately use some like minimum GUI on. That's pretty cool. All right. Well, I won't stop it anymore. If there's any questions from the class, otherwise we can jump right into it.
Cool. We all
All
still
right.
good? Even out? Okay. Awesome.
Cool.
Keep going. Thank you so much.
Yeah. So let me share my screen once again.
We're seeing what you're seeing. You might want to zoom in a couple of ticks. At least for me, it's small. Maybe a couple more.
Boom, boom, boom. So I'm gonna do this one too. Okay, so I think this is still a bit on the kitties, but the front end is on the kitties. Okay, so I have two repos open. I've already kind of built and compiled all the packages, so so you won't see kind of like all that, which takes quite a bit of long time. So I'm gonna run the node. What's going on here is a Substrate node is running with the role authority, right? And we're building blocks. So as you can see, new blocks are being built. Block number 3 just got built. And blocks on Substrate by default are aiming for every 6 seconds. And then we have the front end template. And the front end template is going to look for the node running on the port that it's running on to connect to it. So once the front end template runs, everything is going to be visible to us. Okay, so right out of the box, we have a lot to work with here. We have a Substrate node in development mode. And we have our block counts, our number of blocks finalized. We have some interesting kitties thing here that we'll talk about. We have some accounts that are created for us, some dummy accounts. Alice is you can think of Alice as kind of the master account that has that authority that allows you to run essentially any function that the code on our runtime exposes to the blockchain. Alice has access to all of that. We can do runtime upgrades. So if there's a update to the code and we have the WASM blob, we can choose that as a file to do an upgrade on the chain. We can do some transfers. We can take a look at all the palettes that we have. So as you can see, we have balances, grandpa, a Substrate kitties palette. We'll talk about that. A pseudo palette that allows us to do a bunch of pseudo stuff. So super user, systems palette, template module, timestamp. So, okay, we have this out of the box chain running, right? Very cool. If I were to take, for example, some money from Alice, send it to Eve. And like maybe 5 units. What's going on is we're seeing these events happen. So Substrate is a very event-driven framework, and every event kind of is defined by the runtime developer to be able to kind of see what's going on chain. It looks like finalized in this block hash, there was a transfer. So Eve got the funds. Great. We would see that in our terminal as well, somewhere. Yeah, don't worry about it. Okay, so that works. what else we have out of the box is this cool UI. This is the Polkadot JS UI. And what we're looking at right now is actually a UI that is connected to the node that we're running. So this front-end template is cool out of the box. I can take a look at the React code. And then, if you want to add anything to the React code to make it, more interactive in a specific application-specific way, that allows it. But if you want to just run the node and just use the Polkadot JS UI, we can do that too. So, for example, what can we do here? We can actually do something that one of the NFT platforms does. So there's an NFT platform on right now on Kusama called Remark, and it uses this very cool functionality of Substrate to create NFTs. So there is this function called system.remark. And what this system.remark allows us to do is essentially like graffiti the blocks. We can put anything we want, any type of data we want onto the block in bytes, of course. So I'm going to graffiti, how does this go? Bytes, text to bytes. So I'm going to say Emre was here, and we'll get the bytes. Those are not the bytes I want. So this text to binary, that's more like it. It allows you to do different types of encoding, but I'm just going to go with binary. Right, so cool. So, and then I'm going to send a unsigned transaction. Oh, signed transaction, sorry. And it's going to include those bytes inside of a block. And what I would like to show you is using the Polkadot.js UI. It's very easy for us to see by taking the block hash, which is the unique identifier of the block. We can query zblock to see all the things. So function calls, right? Like these things that are called extrinsics on Substrate are function calls. Every palette is going to have some sort of exposed functionality. So system is a palette, remark is a function on that palette. So I'm calling system.remark, and the way that the chain kind of stores that information is in the block's extrinsics part. So all the extrinsics that got called for a given block are listed, and I can see the bytes that I've created. So this is kind of like a hacky way to create NFTs, because if you have a NFT in some sort of an encoding, you can include it inside of a block, and it'll just get stored on chain. Very cool. And you can do something like if you were to check the uniqueness of the bytes, you can check all the system.remark calls on the chain to see if a specific type of NFT exists. And if it exists, you won't allow it to get created again, making it unique. So that's one use case of system.remark. Right, so what does this mean in our code? So let's take a look at the folder structure here. So we have a node, we have a palette that's defined as kitties, we have a runtime. So let's start with runtime. Runtime / source.
Could you zoom in a couple ticks on that?
Yeah, thank you for reminding me.
Perfect. Yeah, that was good.
Whoop, maybe one too big. All right. So this is the runtime code of a Substrate node. A lot of importing of different types of modules. But what I want to look at is this specific part called construct runtime. So this is where you can choose to include your frame palettes. As we see that we have included a system palette, a randomness collective flip, a timestamp palette, aura, grandpa, balances, transaction payments, pseudo palette. So if we were to like maybe delete the pseudo palette and then recompile everything into WASM, included as a runtime upgrade, and then included in one of the upcoming blocks, that pseudo palette would be removed and the pseudo power would be omitted from the chain. But if we were to add a different palette here and then include that in the next runtime upgrade, the same thing, but for including a palette. So if you were to, let's say, take a palette and wanted to develop your own palette. So this is kind of the structure of a palette right out of the box, right? So we have this public use palette. And then these are some hand-wavy things called macros. This is a really useful way to include code into your code. So this macro is going to include a frame support called palette. So it's going to expose a bunch of functionality that we use for developing palettes. So for example, here we're defining the struct, which is going to be that palette. We're going to have some macro called palette config that's going to allow us to configure that palette. And then we're going to have a palette call macro that's going to allow us to implement some callable functions, right? So what I'd like to do here is I have some, I have a palette that is pre-developed. This is a kitties palette. And what the kitties palette does is that it allows us to create non-fungible assets on chain. So I'm going to create a kitty. Okay, so I just created a kitty on chain. This has a unique ID called the DNA. It has a gender. It has an owner, which is a wallet ID. And it has a price, which could be set as not for sale. But we can set a price on the kitty. We can say 100 units for this kitty. Boom, that's going to get included in a block. Price gets changed to 100. And we can even transfer ownership of that kitty. So this is analogous to transferring a non-fungible asset. Now the owner is going to change. Okay, great. So all of this functionality is enabled by the kitties palette. So let's take a look at this real quick. And I want to take a pause here since we've been diving into code and stuff. Does anybody have any questions at this point in time? Nope. All right.
I think if the class doesn't, yeah, it might be good to refresh a little bit. If you haven't looked at Rust, it's a really interesting language to be writing in. But in general, I would suggest a lot of this is boilerplate, right, that we're looking at. And those macros do some magic things to help implement a whole bunch of logic in the background for you. but what we're looking at here is that framework that Emre is you're putting together is great. It's a good example of you just need a couple of sections in the code and you fill these out with the actual core logic that we're about to look at for the kitties, and you're done, right? So your job as a designer using this substrate system is mostly focused on exactly what we're looking at right now. It's filling in those code blocks that are have these macros above them that do something special. Like, I'll let you dive in.
Right, exactly as Dan said. So this palette used to look like this. And once the functionality was added, now it looks like this. So what is some of this functionality, right? So we have a gender, right, which is an enum. So we can define a enumerator that has multiple options, and we can use certain types of macros to allow ease of use of that defined structure. Here we're defining a struct, and the kitty struct is going to have some properties, right? So it's going to have a DNA, it's going to have a price, it's going to have a gender, it's going to have an owner, which is a type of account ID, So then we're going to need to have an idea of storage. So how do we store these things on chain? So this is where the palette storage macro comes into play. And you can have different types of storage on Substrate. Substrate makes it really flexible for your different types of variables and objects that you want to store. So we have a storage value, which is a single value, a simple count of the kittens that we have. We have the type of kitties. So if we have multiple types of kitties, we're going to want to have a little bit more complex type of storage structure. So we can use what's called a storage map that allows us to create a map, a key value pairs of kitty types. We can track the kitties owned by each account by using a storage map as well. So storage map is this kind of more complex key value pair storage structure. And then we can have different types of configurations on our palette. So events, again, are really important. As we saw in the front end, when we were running some of these transactions, there were these events that were firing off, right? So these are where we define these events. But first, we have to make sure that it's a part of our configuration to use events. It's a part of our configuration to use currency so that we have this idea of price on the kittens. We can have arbitrary types of configurations, like you can't own more than certain amount of kitties on a single account. Kitty randomness, we want to specify this for creating the hash of the kitty. Or I think maybe actually I don't really understand what the kitty randomness is for. So once we have our configuration of the palette of the different types of things we want on it, we're going to want to actually create so we have a configuration we added events to our configuration. So let's see what it looks like to have events on our a palette. So we created a event called created. Once a kitty gets created, once a kitty gets transferred, once a price is set. And these are really important. Kind of, if anybody's coming from a JavaScript development background, these are very similar to the JavaScript events. You can set a pub sub type of publication subscriber type of interaction in your runtime to do certain type of things when certain type of events fire off. This is exactly what that is. And what's really important here is we can define our type of errors. If any type of error, like too many kitties owned, duplicate kitty, overflow, not the right owner, transfer to self, all these things we can have defined that change the way that the palette behaves when certain type of things happen. Similar to how we just called system.remark, in the implementation of the system palette, there is a public function called remark. Similarly, we have a public function here called create kitty. So if I was to go to my front end, look at my palette interactor, click my Substrate kitties palette, I can see that there's the create kitty function, right? So this is exactly where that is defined. We have a function called transfer. We have a function called set price. So that's something that I called earlier. Essentially, all your business logic is in like mint kitty, so these are unique kitties, right? So all of your business logic is going to live in this palette for this kitty functionality. Cool. So that is essentially, we're at the hour now. We have gone over what Polkadot is, what Substrate is, what it's like to run a Substrate node, what it looks like out of the box, what it means to develop on the Substrate framework, and what it looks like to use some of our tools. So right now, maybe we can take a look at one of our live networks. Let's look at Kusama. So Kusama is that canary network that I talked about. Looks like this node is having some issues. Let me switch nodes. And what's cool about Polkadot.js is it allows us to use different nodes to fetch information from. Okay, oops, maybe I'm in the wrong tab. There we go. Okay, as you can see, this is what's going on. Some recent events are happening, some blocks are being built, and blocks are running around 10 seconds, which is not the target, but I think everything is fine. You can have, we have our governance tab, so we can see what's going on in, different types of updates that might be proposed. And here, we can see all the other parachains that exist on Kusama. So, for example, let's go to, I want to check out, which one do I want to check out? I kind of want to check out, let's do Kilt. So Kilt is an identity chain. So if you were to maybe develop a identity decentralized application that does identity and it uses Kilt, it would be very simple to just go to Kilt tab, go to the developer tab, check out some of the abilities that Kilt allows us to have. I assume they have something called identity. We'd have to dig into Kilt's.
I think it's the DID palette, decentralized ID.
DID, DID.
Yeah.
DID lookup. So this is like identity lookup.
That's cool. So this application you're looking at is pretty interesting in the sense that you're able to go from developer on your local machine and then explore a relay network and a parachain all just by clicking a couple of buttons. And you're also able to look at some of the core functionality as a developer, like what you can plug into and build applications on top of. So like I think this is a pretty nifty power tool to be able to play around as a developer, especially in the Polkadot ecosystem.
Yeah.
Unfortunately, it's also used by a lot of people as the wallet of choice for everything, and it's not very user friendly for those who don't know what's going on. As we've just spent an hour on, I still run into a whole bunch of problems and can't figure things out a lot of the time. So
yeah. And if you want to interact with it through just your JavaScript app, you're able to tap into some of the APIs that are also open source. So Polkadot API allows you to have your own front end, because essentially this UI is using that exact same API to load all these informations. So the composability is already there. We have all of these parachains that have specific use cases, and then we have some APIs that allows you to interact with them. All you have to do is come up with ideas to compose these things together and actually make useful tools. And Polkadot similarly has a bunch of parachains running on it. For example, Astar. Let's switch over to Astar. I think Astar allows you to run EVM. It has a EVM runtime, so you can also call, let's see, ETH call. So it has an Ethereum palette that I implore exploring. Allows you to execute Solidity smart contracts on their network. So let's look at Astar documentation. Staking, core features.
So, like, if you wanted to build an application that lived on Polkadot, but maybe you didn't want to touch the Substrate stuff, you want to plug into, hey, like ZK Sync, but now based on this Polkadot ecosystem, different blockchain than Ethereum, right? So there might be reasons you'd want to do that. I wonder, I think we lost the class. I don't know, Tim, if you want to try and plug the phone back in, or if we lost that connection. I know we're still live on AirMeet here. There it is. It's coming back. But in the context of like, what, in your opinion, now that we've seen kind of like end to end, all the way from like what Polkadot is, what parachains are, and how to potentially build them in the context of kitties, what if I just want to use a parachain? Like, what does that look like?
Yeah, absolutely. So for example, we talked about Astar and class. I think, did we lose you there? Did you lose us?
No, we're all good here.
Cool.
Thank you.
It's just a video.
You guys heard everything? So here is a UI that Astar has developed. So Astar is kind of has a lot of functionality as a parachain, and it connects to your wallet, and you can do, let's say, staking. So Astar has developed this UI over their staking network as a minimum staking amount.
That's interesting. Yeah.
Yep.
Because that's a whole different topic than like staking to secure a network, right? I'm not even sure. Maybe somebody in the class knows more about dApp staking in general, because it's kind of an interesting topic. Has anybody heard of this? If not, it might be a tangent we can explore at another time. This is super cool. I wonder if anybody has any other questions about kind of what we went over so far, and maybe follow-ups as to like how we can learn more as we can jump into next. So open for you guys. We went over a lot.
Yeah, go ahead. If any of you guys want to ask, go for it. Now's the chance. Doing all good?
I think I have a question for the class. So we have this environment now in which we can develop these decentralized applications. And so, like, what is worth decentralizing in your view? What would you like to see as a decentralized app? What are some ideas that are worth mentioning in this decentralized world that play into this idea of decentralization?
How about we have like 3 people answer this from the class? So just raise your hand. Yeah.
You're
Go
working on
ahead.
something.
Yeah. All right, who wants to go for this?
I know you guys want to. I'd love to hear some of the context of what you guys are working on, especially, and this is actually maybe preview, the assignment for today is going to be to tell us a little bit of a tech check pulse. We've heard from Algorand and Ethereum and Polkadot a little bit about like what platforms exist to build dApps on top of. So now that you know a little bit about what these are, it doesn't have to be Polkadot. Like what platform are you guys thinking about building on? And tell us a little bit about why in the context of what you're building. Don't be shy.
What's the question basically exactly?
What platform are you working on building, and like some of the other aspects of kind of your project?
Yeah.
To be clear, yeah.
Okay. We can go.
Okay, yeah, go for it. I'll pan the camera. There you go.
Hi, first of all, thanks for your time today. We are looking to build something in the healthcare space. So, we'll be working with a lot of like things like healthcare data, verified documents in terms of patients, right? And at the end of the day, the ideal scenario is that we will have like hospitals or insurance companies working with our data within the entire flow, right? So we were wondering about what to use, and there's a good chance that we won't be able to use like public networks, right? Because a lot of these organizations or entities wouldn't be willing to give their data out in public, right? So we were looking at the enterprise networks, for example. We were researching into something like Hyperledger, right? We can use like Hyperledger Fabric or Sawtooth, things like that. And we were also looking at some of the public protocols that allow setting up our own private networks. For example, we know that with Ethereum, we have the clique, which allows us to set up our own private network, and then we can go from there, right? So we were looking into those.
Yeah. Dan, do you have any thoughts about that?
Yeah, I think it's a really interesting problem space is how do we use public ledgers that is transparent to everybody for very private information that we never want to be released, right? So it's kind of this juxtaposition of needs and trying to like figure out what blockchain does well in healthcare and other like sensitive information. It's a big problem space. Enterprise solutions have definitely been thought about for a while. Consortium chains, as they call them, where you have a private network that talks to a public network as like a waypoint. That's definitely been talked about. I'm really excited what can come out of potentially in the context of Polkadot, building a private network that has that consortium feel with a relay chain, because the guarantees are much more than a state root, which most people are talking about in consortium chains. I think that it's called Baseline Protocol. I don't know if you guys have pulled this up yet. This comes off of the Ethereum Foundation, I believe, and a few other people have come together. This is a consortium chain that talks back to the Ethereum mainnet. And they're doing some interesting stuff in the background, last I checked, using enterprise Ethereum that talks to mainnet Ethereum, public Ethereum to do this. Other interesting plays that have to deal with HIPAA compliance and things like this. I think it's, oh gosh, what's the name of it? Burst IQ. Burst IQ is one of these platforms. Have you guys seen these guys in the space? No. It'd be potentially worth interesting what their approach is, because I think they pivoted away from healthcare explicitly, although that was their play for a long time. Increasingly, though, the thing I'm super excited about, and something that Berkeley is really interestingly focused on, is zero-knowledge proofs. So if you guys haven't explored that problem space yet, talking about getting into tech deep dives, there's some crazy stuff going on in that world. In particular, I think it's going to really revolutionize, maybe even blow up the industry as we know it today in that few years time frame. Because everything we looked at today with like building out a blockchain, like even that's relatively user friendly once you start to get into it as a developer. The zero knowledge proof stuff I'm really curious about, and that's like you still need to know hardcore math, and you have to be able to program this hardcore math into code in like novel ways. So it's not quite user friendly enough to build applications on mostly, but that's changing like this year.
And I think to add to your point, Dan, I think ZKPs have really revolutionized the space, because before that we were mostly looking at on-chain, off-chain solutions which weren't really working because of the integration and the security measures that were coming in. And I think with that coming in, we are really starting to see better things that are like scalable and more secure. So yeah, that's a really
There's some really cool stuff there. The other buzzwords are proxy re-encryption. NewCipher is a really interesting project that touches this. And I think we'll see some really interesting interplays, again, in the Polkadot ecosystem between interesting zero-knowledge systems that can then talk to the rest of the network through cross-chain communication. Manta, actually, I believe, came out of Berkeley. They're alumni out of there. So, like,
I think Harvard, actually.
Manta, the Manta network, there's a bunch of people from UCB.
Okay, so maybe it's both. Yeah.
There's some, I know a colleague came out of here too. So there's a lot of interesting parachain projects in general that have come out. But Manta in particular, they've got this zero knowledge connection so that you could potentially shoot off a message to them to run some private logic. And I think they just launched private contracts where you can basically have a hybridized contract that's semi-public and deploy applications with all the inputs are private. So it'd be like everyone can audit what the contract does, but no one understands who's interacting with it, when or why. So stuff like that is really, it'll change the game and what's possible with this consortium stuff for sure.
Yeah. And to run off what Dan said, which was extremely comprehensive, ZK Snarks is what I wanted to mention. I would advise not to build.
Manta also uses ZK Snarks. I think so.
Yeah,
exactly. I would personally wouldn't build on Hyperledger myself. I would build on a network that's well established and has security on it, and use things like threshold cryptography, such as homomorphic encryption that Dan mentioned, so proxy encryption that allows you to run computation without knowing the origin of the data, ZK Snarks. And so there's solutions like Manta, like NewCipher, which I think is Threshold now. And so, try to utilize those, offload your computation. You don't have to do the whatever polynomial calculation or whatever ZK Snarks do anymore. Like, you don't have to develop that anymore. You just have to, so because, healthcare data, it's very expensive to store things on chain, so you're going to have a lot of data that's going to be, megabytes, gigabytes. That's way too expensive right now in the space where the space is in terms of storage on chain. So ZK rollups, lighter chains are kind of like probably the approach that I would take with healthcare stuff, especially.
Cool. I'm excited to see what you guys do as a project in general. And there's a lot of tools to potentially do it long term. But again, thinking we've got just a couple of months left to do this, being focused on what's the MVP that could actually be like demonstrate what you're trying to do in some way. And it could be that using something like Substrate is an interesting play, that it has the parts, the components that you need. Or deploying this on one of these parachains that has the zero knowledge stuff. Or I think Starknet is coming online now. So this could be something to play around with as well. Lots of cool stuff. And I wonder if Algorand has to have a solution to this. I'm not sure. We have to ask Fabrice.
I looked into it, but I don't think so. Another advantage I see that Polkadot has here is like there are only very limited chains right now that provide the support for sharding inbuilt as Polkadot does, like on the same level, right? And like we just were talking about in terms of the data, when we come to healthcare, like blockchain is resource intensive, right? So I think in terms of that can also help us when we tie everything together. And like you mentioned with Hyperledger, the issue is they leave everything to imagination. So it's so customizable, but that also has that you need to start up everything from yourself, like from the scratch, even in terms of setting up the network, right? Mm-hmm. So like you said, just building the MVP within 2 months with that, with pluggable consensus and everything, it can get difficult in terms of managing that. So yeah, that's a really good point.
Yeah. I think one of the things that's really cool that was talked about a little bit is this runtime upgrades as well. So like you can build a smart contracting system that has upgradability in it, but it can be fraught with danger and error, right? And this is one of the things that can be exploited pretty heavily. And that's not to say that runtime upgrades with the Substrate model are necessarily going to be better than that. In fact, they could potentially be worse if you do them wrong. You could totally blow up your entire network as opposed to just breaking your chain or your application specific like contracting stuff. But the upgradability is definitely core to whatever's going on. So if you're thinking about an MVP to get you started and even to launch and then add functionality later, that's kind of the path of almost all of these parachains right now. There's a lot of optimizations that need to come online for some of the special logic that people are demanding to actually be runnable in the context of the sharded Polkadot thing, because there's just a lot of stuff that needs to get optimized. But yeah, so that's super cool. I wonder if there's any other questions from the class or people wanted to discuss some of other projects that we've got going on.
Yeah, how about we have like one more quick share and then we want to wrap up. We have a lot of announcements for today. So could we have like one more team who'd like to share from this side of the room? Okay, yeah, go for it.
Just a little bit.
Yeah, you want to come a bit closer?
Yeah.
Okay, thanks.
So our team is working on like NFT fundraising for musicians, and I think we're thinking about using Polygon just because of the gas fee that Ethereum has, and it's cheaper. So yeah, very quick. But yeah,
Cool.
Because we're not working on like that much of a technical problem, it's more of a business play. So just choosing the cheapest option for the consumer. So,
Okay. That sounds cool. Yeah, there's a lot of things. In fact, I think that would be the last thing that I show before we go to announcements. Let me share my screen real quick here. You able to see what I'm seeing? So here we've got this really interesting application that's built on top of one of the parachains. Specifically, it's actually StateMine. So StateMine lives on Kusama, right? And I'll share these links here for you guys. And what you can do with this is it's effectively the answer to OpenSea, at least thus far, for anything that's NFT related on specifically Kusama, or really Polkadot could also do this. So here's like an NFT that I think I might have gotten blessed with earlier in the adoption of Kusama. And basically, right, so here it was minted effectively for free, right? They were giving these out for very, very little money. So talking about end users being able to function on this app, it's pennies still to mint and to use NFTs on Singular. But to bring this connection back to the Polkadot side of things, we can see back on this, the Polkadot's JS apps again. I'm connected out to StateMine and I'm looking at the chain state. So in the developer mode, right, I can go and identify that the thing that this whole application is built on is actually, it's just saying, hey, look, I want to connect to this network and look for this particular asset. And what it's searching for is exactly the same information over here. Is I'm querying that one of these palettes. It's a Uniques palette. This is really the fully built out version of that Kitties palette that we saw. That's actually been like audited and stress tested by pros, as opposed to just like kind of a cute toy. And in there, we have some assets that are developed with an index of what that asset class is, and then which asset in that class here. So we can see that there's 30,300 or whatever of these birds, and this one is owned by this address over here on StateMine, right? So I would encourage you, if you want to look at NFTs in the context of what Polkadot it has to offer, this is probably best in class for now. And but then with that Parachains info, there's a whole bunch more NFT platforms that are being developed that you can definitely look into as well. So it's not just Polygon. There's plenty of other places, and I believe Algorand has some answers to this as well for doing cheap assets and more optimized to a particular use case. So something to consider. But cool.
Awesome.
Right. Well, with that, Emre, I think like we might call it good.
Yeah, thank you so much for presenting. Let's give a round of applause to Emre. Just count the clock.
Thank you for having me. Thanks, Dan. Thanks everyone. Good luck with your presentations and your dApps. And don't forget to tap into some of these funding resources that I mentioned. It's a lot of money out there to be given away. So yeah, if you have any questions, I will just kind of like leave my email in the chat. Feel free to reach out for any type of, help or ideas, whatnot.
That's awesome.
Thanks.
Well, thank you, Emre. Really appreciate it. Cool. Well, then I guess we'll catch you maybe a little bit later this evening. I'll hit you up after.
Yeah, we have a lot of announcements for today.
Okay. All right, we'll go to announcements.
Okay,
Ciao.
great. Cool. So we just have a couple things to share with all of you. Do you want to present your screen on share screen on AirMeet? Yeah, let's go ahead and do that. Okay. Awesome. So we're just kind of sharing out the Slack channel. I'd already kind of sent a message for today. Sorry, give us 1 second.
No worries.
Oh, you have permission.
If not, we can just kind of.
I know I'm super excited for Thursday's class. I can't be there in person, but Yatsui, right, is going to be. He's effectively a legend. When I told people he was coming to my class, some people I know, they're like, "Whoa, like this he's coming to your class?" So,
yeah. I know, crazy. Awesome. Okay, so yeah, for this Thursday, again, we are having our wonderful in-person event with Yatsu in Sibley Auditorium. So that'll be super exciting having him come out in person. It's going to be kind of a fireside chat with Tommaso as well. So they're going to be up on stage. We're going to hang out in the audience. So for that, Yatsu had actually asked us to share with you all 2 of these articles that are right over here that you all should read before coming to the class on Thursday. He said that they were super helpful for giving you guys background about what he does, as well as kind of just overall things that he wanted you guys to learn. So just definitely make sure to register for the Eventbrite for that. The next thing is to register for office hours for Dan, as we know, and Tommaso. As we know, the final pitches are coming up next Thursday, or next Tuesday, sorry, March 15th. So that is going to be a big day to look out for. That's basically our midterm 1. So essentially in that, I've included links to the 2 Slack messages that one Tommaso sent right over here. So this was like, win a pizza evening for the team that makes it to have, come in person for pitch session 1.
I'm sorry, guys.
Well.
Could you share screen on AirMeet so we can see that as well?
Yeah, we're having permissions issues.
Oh,
yeah,
strange.
so we're just kind of having the TV in the background.
Okay, fair enough.
Yeah, sorry about that.
Something I can do, I'll just put the message in the chat. Yeah, it's also in the Slack.
Yeah, everything's in the Slack. We're just sharing you guys links that you already have. Awesome. Yeah, we can send the rest of everything is in the Slack, so you guys can check it there. Yeah, so make sure to prepare for the pitch. We have some links that Tommaso had included right over here, which was inspiring pitches from GitLab, as well as Y Combinator and Justin Can, who sold his company. So you can use those as baseline pitches and kind of build off from that. That's kind of what we're looking for this first midterm. And then secondly is for some of the other to-dos, those are included there. We have a mandatory Pulse Week 7 survey. So make sure to fill out this individual Pulse check. It's really helpful for us to know, what are your contributions to the team? How well are you prepared for the pitch, and anything you'd like to share with us so that, you guys can talk to Dan and Tommaso during office hours as well. So yeah, and Dan, was there anything else that you had?
Well, I can definitely speak for myself in terms of getting those office hours in. Notionally, I think I've closed it off to about 24 hours in advance. I'd like to know the day before so that I can actually schedule it into the rest of my day. But so please sign up for Friday and Tuesday is when I have these open. If those times don't work for you, please just do a DM me on Slack and we can figure out a different time with your team. I'd love to be able to talk to every team about what they're doing to get a sense of what your technical aspects are, what you're thinking about so far, especially in the context now that we have seen each of the 3 platforms that notionally we we'd like you to target. It's like something Ethereum, Algorand, or Polkadot-ish related. So I can potentially help steer you right now while you're still architecting things in a hopefully better direction. But up to you guys. This is just an open offer to help you if you'd like it. And it doesn't necessarily have to be the technical aspects. If you want to talk about architecture, whatever it is, hit me up.
Awesome. Okay, so with that, we are also announcing a new thing. Or sorry, any questions for that? Yeah.
I'm just wondering, it says final pitch for this midterm. When does the class end? Is it
Yeah. Sorry. Okay. Wording wise, it's basically our round 1 pitches. So we're going to be having round 1, and then we're going to be having round 2, which is sometime in mid-April. So there's going to be around 3 to 4 weeks in between your round 1 and your round 2 pitches. And then finally, there's going to be the final pitches, which are going to be happening the week before Dead Week, because the goal is to basically choose the team to participate in the Collider Cup, which is the Innovation Collider Cup that's held in the Sibley Auditorium, to kind of like choose the team for seed funding and investing for the startup. Yeah. So with that, sorry, Dan, go for it.
I was going to say the 15th is, I'm getting some feedback. The 15th is definitely the first and lowest pressure pitch. And then I believe later in next month, it's about mid next month, we're going to have a second pitch, which is a little bit higher stakes. And then the 28th is really the final pitch. That's the deadline. That's the most of your grade comes from that 28th, April 28th. And then May 6th, I believe, is the Collider Cup. So we'll have a few days to kind of evaluate and pick somebody who gets an automatic A+ and goes to the Collider Club from there. So it'll be a lot of fun. And so lower pressure on the 15th, but not no pressure. Like there's still a decent amount of things that we'd like to see from what you guys are doing. And doesn't mean you can't pivot, but have something ready to pitch that sounds convincing, at least to you guys for now. And then we can go from there.
Yeah, and for the pitch, we might have something afterwards where we can all like go out for dinner or do something fun to celebrate. So yeah, stay tuned for that. All right, so with our final thing we have today is the teaching team. All of us have agreed that we wanted to start doing this, holding the student of the week and the team of the week to start recognizing some of you guys have had some extraordinary effort and what you guys are doing. So yeah, with that, we can have a drum roll, please, for the student of the week. And we have Leah. Give a round of applause. You want to stand up? You want to stand up? Yeah.
Then thank you.
Yeah.
I want to thank my parents. So thank you.
Yeah, so another round of applause.
Yeah. You want to turn the camera for a quick bow on Andy?
Oh, yes.
Yeah. Got to say hi to the people back home, right? We want to see. Want to see that.
It's okay. Sorry, Dan. We'll do that next time.
Next time.
Camera. Awesome. Okay, next up we have the team of the week. So again, drum roll, please. And that is Team Clutchy. So give a round of applause. Amazing. So if the team would like to stand up. Or are they not here today? Are they online? Okay, well, that is all good. You know, we were kind of awarding Team Clutchy for running an exceptional customer survey that yielded really key insights into their market, as well as developing a really great prototype for their product. So congrats to Armand, Florent, Julian, and Nicholas. Once again, a round of applause. Awesome. So yeah, definitely look forward to be recognized in the rest of the weeks. We're looking at everything that you guys have done so far. So yeah, great job and keep it up for the final pitch, for the round 1 pitch. Yeah.
Awesome. And we'll see you guys Thursday. It's going to be fun.
Yes. And code word, it is, I need to remember. It was parachain. Yes. Code word is parachain. So definitely fill out the attendance form as well. And thank you all for coming. Awesome.
Hasta la vista.
That's all we have for today.